Rich Mayer from UC Santa Barbara. Still the #1 most published person in educational psychology. Rich Mayer.
Oh, gosh. Well, thank you very much for that introduction. Wish my dean was here. Well, I'm really pleased to be at this conference. We're all here because we're interested in games for learning and for assessment, and I really appreciate the invitation. Thank you, Eva and Greg, and everyone who is involved in this conference. I think I've learned about a lot of very exciting projects, including the ones that just preceded my talk. And I personally am very excited about the potential of games for learning. But of course, I think what I want to do in my talk is take an evidence-based approach and see what do we know from work that's been done that could help guide the design of games. As some of you know, for many years, I've been trying to apply the science of learning to education. So in my own department of psychology, people think my work is way too applied, and my colleagues in education think it's way too basic, so I'm kind of in nowhere land. Throughout my career, my main goal has been a focus on how can you help people learn in ways so that they can take what they've learned and apply it to new situations. And that's really the classic issue of transfer, which has been central to both psychology and education from the very start for more than 100 years. So I think this is a very basic question that we're all working on. More recently, I've been trying to focus on how to use computer games to help people learn deeply, learn with understanding so that they can engage in transfer. And today I want to share with you, at least briefly, the fruits of our research program at UC Santa Barbara, and also take a look at several meta-analyses that we've done that look at all the research we could find that's been done to date. I like to break the field of research on games for learning into 3 different genres, what I call the value-added approach, where the focus is on the question of which features increase the instructional effectiveness of a computer game, the cognitive consequences approach, which focuses on the question of what is learned from an off-the-shelf game. Do people learn anything useful from playing a computer game? And the media comparison approach, in which I'm not that interested in, but a lot of people ask this question. It's probably the most asked question. Is it more effective to learn from games or from conventional media? It's almost impossible to answer that, but I'll put it out there. The rationale for looking at this question, I think, is that games for learning have such great potential, and they're so exciting. And to come to a conference like this always energizes me because I see the wonderful things that are going on. But I think we're just beginning to test this potential in scientific research. I think this is a case in which the technology is way ahead of the science. And I think eventually we want game design to be consistent with evidence-based theories of how people learn and research evidence. I'm not going to spend much time on the science of learning, but since I'm a cognitive psychologist, I have to have one flow chart. So this is my flow chart. The idea is that as we're learning from a game or from anything else, information is coming in through our visual channel or our verbal channel. The first set of arrows here, selecting, is we have to pay attention to the relevant material. Then the next set of arrows is we have to mentally organize it. And then the last set is we have to relate it to prior knowledge from long-term memory. And I think meaningful learning always involves active processing of that sort, attending to the relevant information, mentally organizing it, and relating it to prior knowledge. And that's what we're trying to accomplish, I think, when we talk about engagement in games. We're talking about cognitive engagement of this sort. You know what? I think I'm going to just use this microphone. Ah, it's so tall. Actually, I do appreciate this guy here, too, because he makes me feel tall. Oh. Ah. Perfect. It's not intimidating at all. So let me briefly look at research in the value-added approach, which is really what I want to spend most of the time on. So in this approach, we take a base version of a game and compare it to the exact same game with one feature added to it, and look at differences in student learning, and in particular in transfer performance after playing the game. If we get a big improvement for the enhanced group, then that tells us adding that feature was helpful. And if we don't, then we know it wasn't helpful. So let me just look at a few of the studies that we've done in our lab recently, or really over the years. The earliest studies we did were on a game called Design a Plant that was designed by James Lester at North Carolina State University. And in this game, you travel to another planet, and you have to design a plant that would survive there. You have to choose the roots, the stem, and the leaves. And you have this little character called Herman the Bug, who's in the left-hand corner there. Do you see him peeking out? Who kind of guides you along. In the base version, the Herman the Bug communicates in printed text on the screen. In the enhanced version, he actually talks, so you hear a voice. In the studies that we've done, I think that's over 9 different experiments, people learn much better if Herman speaks rather than if you have printed text on the screen, with a very large effect size of 1/1. So we get much better transfer performance from that slight modification. Another thing we can look at is the language that Herman uses. Either have him speak in formal style or in more friendly, personalized style, or what we call conversational style. What we find in this situation is when he uses conversational style, people perform much better on the subsequent transfer test over the course of 5 different studies with a very large effect size. Is this making sense? I better put my glasses on so I can actually see you. Oh, you're still there, thank goodness. Another issue to look at is, well, maybe we should have both printed and spoken text. A lot of people think then people can choose which version they want to pay attention to. But when we compare just the spoken text versus spoken plus printed, what we find is, in both of the studies that we did, that actually adding printed text to spoken depresses performance slightly on a transfer test. So it's better to have just the spoken, not spoken and printed. Another issue concerns whether it's important for Herman's image to be on the screen, whether we should have that little green-headed guy on there. So we compare the base version, which has him there, to a version where he's not there. You only hear his voice. And what we find in a series of 4 studies is it really doesn't add much to have his image on the screen. That's really not what is carrying people's feeling of presence. His voice carries a lot of interest for people, and in this case, we don't need him. Another game is the circuit game. Some people wouldn't even call this a game. In fact, most normal people wouldn't, but I have to. So in this game, you're learning about how electrical circuits work. You have to make certain moves to answer questions. In the base version, you get just kind of yes-no feedback on whether what you did is helpful. In the enhanced version, you get an explanation for why your answer was good or bad. Here, in the one study that we did, transfer performance is much better if you get explanative feedback. In another version of this game, we have it either without self-explanation or the enhanced version is with self-explanation. After each move, you have to, from a menu, select why you did that. You just click on it. So it hopefully gets people to think about why they made the move. And in 3 different studies, we find that self-explanation of that sort helps learning and transfer with a fairly good effect size. Another way of enhancing performance is to ask students to kind of fill out a worksheet as they're playing the game that has to do with, what's the underlying theme. And when we have students work on that worksheet, which kind of prompts them to reflect on what they're doing, that also improves transfer performance. When we add competitive features to the game in terms of showing the score and comparing the score to other people, that does not necessarily improve performance. It really depresses performance for men. Probably because they're already competitive enough, they don't really need that. Another game we looked at was the profile game. This is a kind of a geology game where you have to figure out what geological formation is on a section of a surface of a planet. And some folks get pre-training and what the formations look like, others don't. The pre-training group does much better on a transfer test. So just getting some idea of what it is you're trying to do seems to help. Another, this is an engineering simulation game called Virtual Factory. In this game, we looked at whether the on-screen agent talks in a polite way or a direct way. So the direct way would be press the enter key, and the polite way would be, why don't we press the enter key? Or shall we press the enter key? Sounds a little wimpy, but it actually helps performance for beginners. For engineering students, it doesn't matter. I'll let you draw your own conclusions about that. Lastly, I'll look at Cache 17. That was done by Alan Koenig over here, right? There he is. In this version, we looked at whether having a strong narrative theme, this is kind of a action, this is kind of an adventure game. Having a strong narrative theme helps or not, and in this case, having a narrative theme, which means having a introduction that it kind of sets up why you're playing the game, did not really have a positive effect on learning. So in this case, narrative didn't help. In other situations, it does, but in this particular one, it doesn't. And another thing we did here was to look at giving students a worksheet while they're playing the game to have them focus on the main theme, which is to kind of understand how electromagnetic devices work, because you have to use them in the game. That did have a strong effect. So just a paper and pencil worksheet helped. So overall, when we look at the overall literature, doing a meta-analysis on the current state of the field, all the studies we could find that use the value-added approach, we find 5 principles that we can be pretty sure of, many that I already just talked about: the modality principle, personalization, pre-training, coaching, which involves providing advice or explanation, and self-explanation. They all have fairly large median effect sizes and a fairly high number of studies that investigated them. A couple of things don't seem to work that well, at least in the literature so far. Immersion, having very vivid virtual reality, didn't add to academic learning in the studies that we found. And redundancy, in terms of having both printed and spoken words, didn't help. There are a lot of other factors that there's just not enough evidence for, so there's still work to be done here. Let's see, cognitive consequences. In this kind of approach, we take an off-the-shelf game and ask, what effect, does it have any positive effects? Does it help you learn anything useful? So we compare a group that plays the game versus a group that doesn't play the game for an extended period of time, and then we test them, both pre-test and post-test, on cognitive skills. In studies that we've done in our lab, we looked at both Unreal Tournament, which is a first-person shooter game, and Tetris, which is a spatial puzzle game. For how many of you are familiar with Unreal Tournament? Probably a few of you. It's kind of a classic by now, not when we studied it, but what we find here is that that did not have a strong effect on spatial cognition skills. We are interested in spatial cognition because these are skills that are needed in a lot of STEM fields, including engineering, and we wanted to, and they also seem to block some kids from going into those fields, so we wanted to see if we could use games to help boost those. But this didn't seem to help. When we look at Tetris, which is a classic game that I'm pretty sure many of you are familiar with, 10 hours of playing Tetris also did not have a strong effect on spatial cognition skills in the studies that we've done. So I can say, at least from our lab, we're over 2 trying to look at games. But when you look at the overall literature, this is from a meta-analysis that looks at all the work we could find, the strongest effect is that first-person shooter games seem to improve perceptual attention. That seems to be a fairly well-established fact. Tetris might improve performance on Tetris-like tasks, and some of the other games we don't really have strong effects for yet. So I think the jury's still out on a lot of the other games. Thanks. Lastly, I'll just very briefly mention media comparison. I told you this was my least favorite, and because it's very difficult to have the game and the non-game version of the same material be equivalent. And what we have found, I won't go through all these, but what the overall research says when we look at our meta-analysis is that there's some evidence for science material that games are more effective than conventional media, and also second language learning. There's less evidence for other subject areas. So let me just conclude by saying there are a lot of really strong claims and potential for the educational value of games, but I think it's important to try to take an evidence-based approach. And we're just really beginning to understand how to do this and to accumulate evidence, so I think this is a very exciting field. So here's all the references I talked about. If you don't believe me, I'm sure you read them all. Thank you very much.